Okay. So from whatever we have learned earlier, we'll be using those concepts in understanding what we are trying to do over here. Let me tell you a scenario. There is a company, okay, and this is manufacturing, let's say, 1,000 units of a product, let's say bulbs per day, LED bulbs, 1,000 units per day. It is manufacturing. Now, the problem is you can't inspect all the items. Okay. So what you're going to do is you're going to pick n samples out of this 1,000 units, and you're going to note down that how many are defective, because it's not possible to not get a defective piece on daily basis. So you're going to find out how many are defective. Okay, let's say we want to estimate that how much percent of the output is defective. So it turns out that 5% is defective. But the thing is, you really can't figure out. I mean, we have already seen that mean is not that great of a measure, right? So if I can predict how much variation exists in the quality parameter. So let's say the quality parameter over here is lumens, because lumens is a unit for measurement of light intensity. So we always find out how many lumens a bulb is giving. Okay. So if we can say it varies plus minus x. Okay. So with 95% confidence, let's say if I can say that the average lumen varies around these values like we do in the normal distribution. So I can predict that what will be the output. Okay. I can predict the output of the process. So that's what means is control. If I am able to predict the variation in the quality parameter with certain certainty, with a given certainty, then I can say that my process is in control. But if there is a certain point goes beyond those limits, that means the predictability of the process is less. Okay, so let me give another example. Generally, let's say now off-campus classes may be there. So let's say 10 o'clock, 10 a.m. is the starting point of the class. Class starts at 10 a.m. So some students may come at 9:58, some students may come at 10:02, some students may come at 10:05. Okay, so this much amount of variation, I also teacher understands that this amount of variation may be present. Okay, and 95% out of if 100 students come in the class, 95 students come within these limits. Okay, then you can say that I am 95% sure that the students are going to come in between 9:58 to 10:02. Okay, but if a student comes at 10:10, what do you say? What will be your interpretation about that? Yes, anyone? If any student comes in the class at 10 minutes past 10, what happens? What do you conclude about that student? Would you call that student under control? Yes? Anyone?
Not under control.
Yeah. So why not under control? Yes, Yukta. Why not under control?
Sir, because we predicted that 95% students will die in that time duration,
Yeah.
but that student doesn't.
Yeah. So basically, you are not able to predict that student. Okay. So same thing goes with the production also. So if you can predict, if you can statistically predict a process, output of a process with certain confidence, then you can say the process is under control. But if any point or any sample goes out of those control limits, then we say that the statistical predictability is compromised in that process and we can't be confident about it. Yeah. So can all of you, like the examples which I have given you, I would ask all of you to come up with one example each and explain it like the way I have explained all of you. I'm going to give you right now 20 and 8, 9 is happening. So 8, 13, 14, I will call back all of you and see how many of you can answer that or with a certain example. So how many of you are ready with the answer? Let me call one by one. Okay, Karvi, please.
Sir, we can take an example of a website.
Hmm.
So if the developer says that 95% of the time, the total time that it takes to load is 60 seconds.
Hmm.
And if we take a tolerance of, say, 2 seconds,
Hmm.
then 62 or 58 seconds, like between the range of 58 seconds to 62 seconds, the web page loads. But if at some point when some user is loading the page, the web page might take more than 62 seconds, let's say it takes 65, 68 seconds, or maybe more than a minute, more than 2 minutes, then that becomes a case which is out of our control.
Very good. Shubhangi, yes.
So we can take example of phone battery. So it is said that the phone battery will last for 8 to 10 hours, between 8 to 10 hours. And for some phones, the battery lasts up to say 11 hours.
Okay.
That would be of control, or less than that.
Okay, so you can always say, to make it more precise, let's say we take just a second, sorry. So if I have to elaborate on this, I would add one more sentence. Let's say 100 phone batteries are chosen, okay, and a mean battery life is, let's say, 7 hours, and plus minus 30 minutes, we can say that, okay. So standby, I mean, this is standby time, let's say. So if out of 100 batteries, 95 batteries are lasting within this plus minus 30 minutes, but 5 are not, okay. So we may say process is under control with 95% confidence interval. But if a certain battery falls out of these limits, 95% control limits, okay, so let's say sixth one goes out. I mean, five of course can be out of 95, five can be out. But if sixth one goes out, then we can say the product is the predictability of the of the process, statistical predictability of the process is compromised, and we are not able to predict the variation in the process. So if you are not able to predict the variation in the process, you will not be able to ensure the quality which you are promising, okay. Now one more example after I have told you. Now you can improvise on that. So one more student I saw was, I think, Shubhangi or Yukta, someone was there who had an example. Yes, Yukta.
Sir, actually, I had, but after listening Karvi and Shubhangi, I realized that I misunderstood it. I thought of if we take milk from dairy or vendor, so uh, then if we are taking 1 liter of milk, then it will not be exact. But I misunderstood this the concept.
Did you get it now?
Yes, sir.
So can you give an example? Yeah, Varun, please give example. Yukta, meanwhile, you can think.
Like the company claims that the car has the mileage of 20 kilometers per liter. And on similar conditions, we found that it is between 18 to 22 for most of the cars. But if it is less than 18, then we can say that it is not under control for the similar conditions of highway.
So, what is the meaning of statistical control? I ask it because we are going to use this control word very just like you are eating bananas. So it should be very clear that when we are using the term control, we should know that what is the meaning of control. Okay.
So like if it lies between the predicted range of.
Yeah. So it's about the predictability of the variation. How much you can predict the variation about the process. How much is the variation predictable? If the variation is not predictable, then we may say the process is out of process is not in statistical control. So it is all about prediction. Always remember, whenever we are talking about control chart, control indicates prediction of not mean, prediction of it is about the prediction of the variation, okay, predictability about the variation in the process, okay, how consistent the process is basically. Yes, Yukta, do you have an answer?
Yes, sir. Sir, like it is claimed in the food processor that you can make dough in just 1 minute, but it varies with the quantity in different places. Right?
No, let's say the base is same, everything is standard.
Yes, sir, but then also it varies, not exactly in 1 minute.
Yeah, it is going to vary definitely. But then is that variation under control or not? Is that predictable? The variation which is happening, can you predict that variation? Are you able to explain that variation? Then you can say it is under control. Because variation will happen. Okay. So if you know that this variation is going to happen, when do you know the variation will be there? Let's say we are talking about students entering in the class. So I say plus minus 2 minutes will be there at the time of starting of the class. So when can I predict it? If I am able to predict it, what are the causes? Can you tell? Just make a guess. What are the causes of variation of a student entering the class? Yes. Why do students enter some 2 minutes early or 2 minutes late in the class?
Sir, some may rise late,
Hmm.
and the ones which come early maybe like very punctual, so they get ready fast and prefer to come before.
So,
Maybe other factors like if someone is traveling with the maybe there is a traffic or not, that it is also controlling.
okay, so the causes of variation we can classify into two types. One can be a common cause of variation, another could be a special cause of variation. So let me just write it. Variation causes. So one can be a common cause of variation, another can be a special cause of variation. Okay, now let me give you some examples. Common cause of variation. A student often comes late in the class because uh, the student, the particular student always, I mean, I'll say all a complete general statement that the students generally wake up late in the morning, hence they get late for the class. So it is a common, like most of the students are going to enter it after 10. Yes or no? Okay, so that is, you can say, the common cause of variation because this will anyway be there. But let's say on a given day, the student was not feeling well, okay, was having a fever. So is it a common cause or a special cause?
Special.
So can you predict it? Common causes you can predict, right? Common causes of variation can be predicted, but can you predict special cause of variation?
No, sir.
At times, if you do deeper investigation, you may actually try to find out that whether a variation which has happened because of the common cause or special cause. Let's say if you can't explain it, if you can't uh, say that it is inherent in the process, common causes of variation are generally inherent in the process. Okay, like getting up late in the morning. Just a second. Yeah, so common causes of variation are generally inherent in nature. which are difficult to remove and which will be there anyway. Okay, special causes of variation requires investigation. If you are able to, yeah, generally what happens is that a student fell sick and then came late, very late, because headache and all. So this is a special cause of variation. So very first thing when you are trying to do control, when you are trying to bring a process under control, quality control is, or you can say not quality control, but statistical quality control, you have to identify whether it is a common cause or a special cause of variation. If it's a common cause of variation, you can't do much about it. If it's a special cause of variation, you have to take steps to remove that special cause of variation. Okay. So, can you give more examples, which is something related to your day-to-day life? Let's say all of you give three examples of common causes of variation in your day-to-day life and three special causes of variation. It could be related to anything. So think about it. See, it is very important whatever discussion we are doing over here, because later on the numericals all of you will be able to do easily. But the concept which we are talking about right now will take time for you to digest. So think about it. Common causes of variation and special causes of variation.
then it's easy.
Okay.
But I cannot
But is
do
it,
anything about
but is it really easy?
specific.
Is it really easy? I mean, you can think that I can do this and that, but you may have to change yourself, right? You may have to totally change yourself.
Yes, sir.
Okay. Similarly, the special cause. Just a second. Sorry, lot of disturbance. Just a second. Easy. I mean, if I ask that, is it easy to remove a common cause of variation, or is it easy to remove, once identified the special cause of variation, it is easy to remove the special cause of variation? Which is easier?
I think it's a common.
Okay, so anyone else in the group?
Sir, I also have an example.
Hmm.
Okay, so building upon the website example that I was talking about, so the variation cases that we looked into were where maybe the website takes more than 62 seconds to load. So in that case, there could be multiple reasons why that is happening.
Hmm.
So one of the reasons could be that the user who is loading the page is in such a location
Hmm.
that it is very far very far away from the server.
Okay.
So it might take more time.
Okay.
And that could be a special case, whereas a common case could be that at that point of time when the user is trying to load the web page, there is a lot of traffic. So the page takes larger time to load.
Okay,
according
so
to
very good example. So I can add one thing over here. Let's say you are the server. The server, the processor of the server is laggy. Okay, are you getting what is that? I mean, you have AMD processor, you have Intel, so you have inferior quality processor. Okay, which generally lags and I mean gives a variable performance. Okay, so variation exists because of the laggedness of the processor of the server. Okay, so this is a common cause of variation, and the other one which you have given is a special cause of variation. Now, if you have to remove the special common cause of variation, you will have to actually change the process. You will have to do investment. Okay, which is generally difficult. So removing common causes of variation is generally expensive, difficult, and requires a lot of managerial intervention. If you now look at the company from company point of view, let's say a machine is there, okay, which is producing a cylindrical object with certain diameter. Okay, now a lot of vibration is there in the machine. So because of that, the dimensions vary a lot. Or there is a variation in the dimensions. So predictability is there. You can predict it. Okay, this much will be there because you know how much vibration is there in the machine. But then if you have to reduce that variation, common causes of variation like vibration, then you may have to actually buy a new machine, do lot of changes in the machine. Getting it? So that's why common causes of variation are not generally concerning because predictability is associated. You know the predictability. You know these are common causes, and I know that I can predict it. Okay, because it is happening. But if out of the blue certain other thing happen which you are less known about or which you have less idea about and which has a lot of variation, which exhibits variation, okay, and there is a special cause, then it is a point of concern and one needs to invest. Then you can't predict it also. Okay, so if you can't predict the variation which is coming, then it is a special cause of variation. Now what you do next is identify the special cause of variation, and then like you people have given example that far away location is there. Okay, so what can be done about it? Yes, Karvi?
yes, sir. So maybe we can create a server in that area also.
Maybe we need to increase number of servers. Maybe we need to have an intermediary server somewhere or like a distribution center somewhere. Okay, so once you identify the spatial cause, then you take an action. Then you remove that spatial cause of variation so that it again comes under the predictability. You make it more predictable process. If the process is more predictable, you can increase the quality of the process. Now similarly, Varun Saini अगर fog है, किसी दिन fog हुआ और आप लेट रन करने जा रहे हैं तो उसका कुछ solution है?
So we can check the weather prediction.
Okay, we can check the weather prediction, or you can be better equipped to run in fog also.
Yes, sir.
How can you be better prepared to run in a fog?
Like we can
So we can use it
proper
for
clothes, etc.
You can wear more clothes, you can have a torch.
Yes, sir.
Okay, something like, I mean, there are always ways of doing that. You probably a more scientific way you'll have to. So similar thing happens in the industry because problem solving has to be there. This subject is mostly about problem solving. So here we identify the causes. Okay, so quality parameter, we know the quality parameter. Okay, we measure, take samples and identify the quality parameter and then do repeated measurements on that. Then we make sort of charts are there. We say variable control charts. First, we are going to talk about variable control charts. So we make the charts and we see whether the variation is under control or not. If the variation is under control, that means only common causes of variation are present. And if variation is out of control, beyond those control limits, which we are going to make, then we say special cause of variation is there. Then what do? You investigate the special cause of variation and try to remove that point. Okay, that's what we do in, I mean, this is the premise of, yes.
Sir, it is not necessarily like there could be many random causes also, like something that we can't even point out, or you know, like.
So you'll have to actually label it. You have to do investigation, and the investigation has to be, yeah. Let's say the point goes out, and you are not able to find out any reason behind that. Then you say it's a random.
Okay, so then it initially I thought it would also come under common causes. So it would come
See,
under
randomness is always there. The variation can be, let's say, divide the variation into three components. One is a random component, one is a common variation which is there, which is inherent in the process. Okay, and one is a special cause. So even a process under control will exhibit random causes of random variation. Okay, but the random variation can't be so random that it can't be explained. Generally, let's say a sudden spike is there. Your television आपका अच्छा खासा चलता चलता खराब हो गया. So क्यों खराब हुआ वो? Variation तो voltage में हमेशा होता है, right? Randomness भी होती है variation voltage में. होती है नहीं होती है?
Yes, sir.
Okay, so random variation is भी होती है, but then एक दिन आपका टीवी खराब होता है. क्यों होता है वो?
Yes, वो random causes की वजह से तो नहीं होगा. There will be something special.
So we can always say voltage spike is one of the most common causes of failures of electronic devices. So, but this is a why did the voltage spike happen? See, voltage in our electricity and all, always variation is there, alternating current, right? And you all know about it. So always variation is there. It's always varying, transient state, always in transient state. But on some occasions, because of the faults in the grid, we get voltage spikes. Do we not? So you can always figure out, right? So most of the time, special causes of variation are identifiable.
So, sir, we can say that the tolerance that we are taking, like the plus minus x,
Huh.
that is there to take care of the random causes.
That is there to take care of the common variation and the randomness, both.
Okay.
Okay, so we say basically quality characteristics can, and in the first lecture or the second lecture I have already told you, quality characteristics can be classified as variables and attributes. Variables and attributes. So anyone who can tell what is a variable, what is an attribute, what's the difference between the two? Yeah.
Variables can be measured, but attributes can't.
Yeah. So variables are measurable, like quantifiable. You can assign some quantities with them. While attributes deal with the qualitative information, like defective, non-defective, non-conform, okay, not okay, like that. Okay. So this is what. So right now we are talking about those quality characteristics which are measurable and can be quantifying. Can we uh, measure them and then find out whether quality is under control with respect to these variables or not. Okay. So tell me one thing. What is the what about cost? Cost of obtaining data for attribute will be higher or variable would be higher?
Variable.
Yes. Cost of obtaining data with respect to variable will be higher. I'll show you one video. How many of you know go and no go gauges? How many of you heard about go and no go gauges? Is there anyone who's ever heard about it? Okay, so I'll show you a video of go and no go gauges, which will give you an idea that why cost component we are talking about. Okay, just wait.